Hi, welcome to our next application video for differentiation. We're going to find the equation of tangents and normals. A tangent is a straight line that passes through a point on a curve and has the same gradient as the curve at that particular point. A normal is a straight line that is perpendicular to the tangent, which means it's 90 degrees. And we're going to use this formula, which we're going to explain later in the video, on how to work out the gradient of a normal. All right, let's get straight into example 1. Find the equation of the tangent of the function y equal to x to the power of 3x divided by 5x at the point 1, 4. Well, we're going to use the quotient rule to differentiate this function because it's something divided by something. So here's g and h, and here's g dash and h dash. And here's the quotient rule. So we're going to work out y dash by going g dash times h subtract g times h dash, all divided by h squared. And we're going to tidy that up a little. You don't have to tidy it up. It just might make it easier when we go and work out the gradient. Alright, so when x is equal to 1, we were given the point 1, 4. We're going to use x equal to 1 and we're going to substitute that into the gradient rule. Now here's where it gets a little messy. Be very careful when you type this into your calculator to work out a gradient of about 8.03. We're going to round that to 8 because it's close enough to 8. So when x is equal to 1, we have worked out that the gradient of the curve and the gradient of the tangent is equal to 8. Right, now we're going to turn our attention to the straight line graph because the tangent is a straight line. So y is equal to mx plus c, which is the straight line equation. We've just worked out the gradient of this function is 8. The gradient of the tangent and the curve is the same gradient at that point. So now we're going to use the point 1, 4, which is the point we've been given, and we're going to substitute 4 in for y and 1 in for x, and we're going to work out c. So 8 times 1 is 8, and then we've got this plus 8 on the same side as c, so we'll put that on the other side and get c is equal to 4 minus 8, means c is negative 4. So our equation of the tangent is y equal to 8x minus 4. Here's a picture of what this function looks like. Here's the point 1, 4, and here's the tangent at that point. And we've worked out the equation of that straight line. We just took the graph away for a moment. You'd see that the graph passes through negative 4, which is the value of c, and it's got a gradient of 8, means it rises up 8 and runs along 1. Okay, let's move on to example 2. Find the equation of the normal. And notice it's the same function and it's at the same point, 1, 4. So we're going to skip all the differentiation. You can look through that again if you got stuck. But we know that when x is equal to 1, the gradient of the curve and the gradient of the tangent, which is the same gradient, is 8. So here's our function again, and we're going to put in our tangent. And here's our normal now. Now to work out the gradient of a normal, we need to use this formula. m1 times m2 is equal to negative 1. m1 is the gradient of the tangent, and m2 is the gradient of the normal. So we're going to rearrange m2 is equal to negative 1 divided by m1. So the gradient of the normal is equal to negative 1 divided by the gradient of the tangent. Well, m1 is 8. We worked that out just before. That's the gradient of the tangent. So m2 is equal to negative 1 over 8. So we can say when x is 1, the gradient of the tangent is 8, and the gradient of the normal is negative 1/8. So let's go back through y equal to mx plus c once again. Let's substitute a negative 1/8 now for our gradient. Let's use the point 1, 4, put in y is 4 and x is 1. Let's rearrange this to get c is equal to 4 and 1/8. And let's write down the equation of the normal now. Y is equal to negative 1/8 x plus 4 and 1/8. Thanks for watching.